today I'm going to be walking you through what dynamic programming is. So look, dynamic programming is not in data science domain, but these are concepts that even data science and ML operation people should be aware of, especially those entering AI from business backgrounds because they need to know what's happening on the back end of these algorithms. So foundational techniques basically of dynamic programming are memoization, tabulation for optimizing recursive algorithms, which can be retracked and reiterated again and again without needing to be done manually. Okay. And knapsack problem and longest common sequences, they both are problems done through dynamic programming, where dynamic programming crunches numbers into a dynamic programming table. Okay. And then later initializes them. So let's show it to you, a manual math example of how it's done first. Okay. So basically, let's assume over here that we have weights 1, 3, 4, 5 and values 1, 4, 5, 7. Okay. And the knapsack capacity is where the weight is equal to 7. So over here, we are seeing an empty table, right? Where all values are 0. So let's assume, let's now fill in the table where with item 1, which has the weight of 1 and a value of 1. So let's say we are filling an empty basket with one item which has a weight of 1 and has a value attached of 1. Okay. So how do we fill it with dynamic programming? So, okay, so now look, we have 1, 3, 4, 5, and we have 1, 4, 5, 7 in value. So the highest value we have is 7, and the lowest values combined we have is 1, because lowest values is 1 here, and the highest value is 7. So if we had only 6 present over here, and then 1, 4, 3, 5 here, then the highest value would have been 1 to 6. Okay, basically we just need to create a table from the lowest to the largest value compromised in both tables. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, we start from 0, 1, 2, 3, 4 because why? And again I show you why. Because we have 0, 1, 2, 3, 4, we have weights. Okay, and then we have values from 0 to 4, 0 to 7. Okay, because we have to acknowledge that the weight is 7. Because why? Because the weights are 7. And why only 4? Because 1, 2, 3, 4. 1, 2, 3, 4. We only have 4 digits in both weights and values. So we are only going to select up to 4 over here and 7 up to here because the weights are up to 7. Okay. So now how do we fill in one? Okay. One item in a basket. So we have to now take into account that look, if let's say the one's item, let's say is like item 1 is weights equal to 1, for each weight capacitor 1 to 7, compare what's including them versus not including them. So we just randomly add 1 to all of them because 1 is the only value available. Okay, there's nothing else available before it. Now when it comes to the value of 2, that's when we have to decide, because the value of 2 is 3 and sorry, the value of 2 is 4 and the weight is 3. Okay, why? Because look, the second digit is 3 here and it's 4 here. Okay, that's why it has 3 in the weights and 4 in the weights. Okay, now compare including them versus not including them. If they're less than 3, okay, if the weight is less than 3, we cannot include the item 2. Okay, so now let's see, where is the weight 3? Okay, so luckily there is no, where the weight is less than 3, it is where. Okay, now we shall see where. Okay, so now we cannot include item 2 because the weight is 3. Okay, and we have to choose what is less than 3 or what is more than 3 from then onwards. Okay, because where the value is 4 and the weight is 3, we can't include anything less than 3 and 3 or less. Basically we can only include weight that is 3 or more. So let's now choose all list of values. So we have basically 2 to 7 now. Okay, so 2 we won't include because its weight is 3. So now we will start with 3, 4, 5, 6, 7. Okay, so now if we take a list of values, they are 3 to 7 as mentioned over here, and since the weight is 3, we will be subtracting each value with 3. Okay, and we will be selecting the previous row of values, which was 1. So all the values of 1 were 0, 1, 1, 1. Okay, as you can see. Okay, like it's 1 to here till here, and that is exactly what we selected over here in the max from 1 to here. Okay, and then after 3 minus 3, okay, it's 0, 0 plus 4 is 4, because why are we adding 4 over here? Anyone can understand why we're adding 4 over here? Because this is basically this is 2, right? okay? Because the value is 4 in item 2. That's why we're adding 4. We're adding it with the value. We're minusing the range of items and adding it to the value, okay? Now 4 minus 3 is 1 plus 4, okay? 1 plus 4 equals 5, and then 5 minus 3. So we are after inputting both the initial values of the previous row and the new values we're calculating for the new row, that is 2. We are then selecting the max from them, and then we fill that in the new row. So in 2, that these values get filled over here when we're taking out item 3. This is how dynamic programming fills works automatically, okay, in the backend. Now let's take a look at the practical examples of dynamic programming, okay? So Fibonacci series, okay, this actually is used a lot in stock exchange calculation, technological analysis, and even earthquake analysis too nowadays, because it helps us understand the relative frequency of numbers. Example, economic growth is always 5.5%, 5.6%. It's very non-deterministic in nature. So that's what this Fibonacci sequences tells us, that if something is happening, it won't happen exactly as it is. It can also happen again with slight changes, okay? And we ran this like definitely we have in Python. We create a def keyword for creating a function. We then create Fibonacci, and we create an input for numbers input, and then convert them with memo as a parameter. So if the number is in memo, return the memo multiplied by the function memo multiplied by the number. And if the number is less than equals to 1, then return just the number, because it won't work then, okay? If it's 0, anything multiplied by 0 is 0, simple. So if we multiply, because memo is basically an inbuilt function to help you calculate Fibonacci, okay? So Fibonacci then equals n. Now if how does memo work, okay? It equals to Fibonacci equals multiplied by the 1 minus minus its value, and then memo, and plus Fibonacci n minus 2 value. So now if I choose the Fibonacci equals to, and then it returns me the full memo to the number. Now watch, it's returned me the number 55 over here because I chose the value 10. And now you're going to understand that, hey, you inputted 10 here, Amar, so then how is it returning us 55? It's not possible. Now take into account, okay, so I'll show you why. Now let's use this exact logic. Now starts with 0. Now see, it's 55. Now do you see this is how it's returning our Fibonacci sequences in dynamic programming. Basically, it's taking into account how things are being changed at a constant rate of -1 being added every year to a particular event. Example, if the earthquake happened, let's say 5.6, like the stock exchange actually declined today by -1%, it might decline by -2% tomorrow with -3%, because we're assuming that, let's say, one person or one company is pulling out of the stock exchange per year. So this is not the exact value of what the stock exchange declines by. It's very random overall worldwide. I'm just giving you an example of how the Fibonacci sequences works. It assumes a particular condition related to subtracting the event. Okay, this is how it's working here. Okay, now let's see what is edit distance in dynamic programming. Okay, now this is the more interesting part of dynamic programming. When there are two strings that are so dissimilar, how many strings do we have to change to make the word the exact same one? So let's see, there's kitten over here and there's sitting over here. This is the entire function that's changing the letters basically, for in order for one string to equal to another, basically one word to equal to another, by taking into account how many different letters there are in each and then converting them. Okay, so if let's say I am now using this edit distance function, right? It's giving me 3. What does that 3 mean? That there are 3 letters not present in kitten over here, which I've chosen as a word, which are present in sitting. So if we add them to kitten, we can get sitting. So can I find that out? Yes. So let's say K-I-T-T-N is kitten. Okay. So if I replace, let's say, K with S, that's my first letter. If I replace I with E with I, second letter, and then I add G, third letter. So see, with 3 letters, I'm getting sitting from kitten. That is what edit distance of dynamic programming tells us. So this was just a small intro to what dynamic programming is, and I look forward to towards the next lecture where I will be doing a bit more advanced methodologies into data structure programming. So hope you liked today's lecture. See you next time, next week rather.